Okay, 2.5 to 2.8, I think. 2.5 to 2.8. Yalla. Quiz, you need some formulas here. In the last one we used, in the last quiz, 2.1 to 2.4, I'm pretty sure I used E equals HF, Planck's constant. Okay. For this one, مطلوب, مطلوب بالnote. There's one equation that wasn't asked. It's Coulomb's law, and it's to determine the force on any charge. With the force is equal to in between any two, between any two charges. What's the force in between them? Okay, it's equal to K, Coulomb's constant, multiplied by the charge of the first one multiplied by the charge of the second one. أكيد an absolute value because the charge has to be positive. I don't care if it's a negative or positive. You're gonna put it as positive. Divided by r squared. R squared is the distance between the charge. It has to be in meters. It's squared. Okay. So how they may ask this in the exam? What does Coulomb's law state? Coulomb's law states that the force is directly proportional. Okay, the force of the charge is directly proportional, or the magnitude of the force is directly proportional to the charge, the product of the charges. Yeah, sorry, is directly proportional to the product of the charges. You could say product of the charges divided by the square of the distance between them. Okay, to make sure of this, I just want to check the book. Just in case أنا ما عشان ما بدي أخبص وأقول شي غلط. And my ebooks is tweaked. Nice, nice, nice. Why isn't it working? Okay, 2 point charge model for electric charge. And it's not neutral bodies. I don't think it's neutral bodies. Okay, I'll cut to where I get. Oh, here. Okay, so experiments show that the electrostatic force between two charges is proportional to the charges and inversely proportional to the square of the distance separating the charges. This will, like صراحة, I think this is a question. They're gonna put it like this: electrostatic force. Okay, I think they're gonna get it like this: electrostatic force is, and you have to choose correct, right? Select all that apply. You're gonna put directly proportional to the charges, or inversely proportional. So inversely proportional, I'm gonna write it like this: indirect proportional to 1 over the distance squared. You have to say the square of the distance. The square of the distance. Okay, this is how you write it. Okay, يعني electrostatic force. Memorize it, please. It's F. Sorry, F equals Coulomb's constant multiplied by charge 1, charge 2 over r squared. Okay, or K is actually 9 times 10 to the power of 9, which is not needed because they don't ask you to apply this formula, guys. They only ask you know the definition of it, the theoretical definition. Okay, what's true about neutral objects? We know neutral objects are attracted by positive or attracted by negative. وليد, how يا أخي, how man, how look, عندك neutral sphere, عندك الهيدا let's say positive, positive rod. Positive will attract this negative. Well, eventually there's going to be some attraction force between these two that's going to cause, saying you have to assume that it's neutral. This only happens if they're neutral, huh? This attraction force will start to pull it شوي until they touch. When they touch, خلاص, bam, it's going to become positive, it's going to become like negative or like something, whatever. The charges will change and then they stay attracted. So neutral conductors are attracted by positive, come in attracted by negative. Hold up. Am I tweaking? Yeah, okay. Yeah. See why some people get this wrong, and I just realized why. I was tweaking. Some people will see insulator and they're gonna be like, "Oh shit, doesn't attract. No charge." Habibi, no. Both neutral conductors and insulators are attracted by charged objects. If they put negative, it will also be correct. عادي. كمان also here, if they put negative, كمان it will also be correct. Both of these are correct as long as it's charged. If you want to see it in the book, it's over here. Attraction of a neutral object, insulator or conductor, both of them, they will become attracted by it. Okay. This wasn't in my notes, but I think I'll I think it wasn't in my notes, right? Yeah, it wasn't. But let me just mention it at Saria. Over here, they're saying assume this ball is negative. Okay, nothing is gonna happen here if this is neutral, right? Because it's not charged. But if you bring a negative rod, the positive charges will move to the right, and negative charges will go to the left. And since now you have negative charges on the left, they're gonna repel the negative charges that are here. Okay, just so you can understand, the large sphere did not lose or gain any charge, but it repelled the ball. So it's electrified without really being charged. Electrified, yani, how can I say? Electrified is when the distribution of charges are changed. يعني. Okay, this kind of polarization is due to the redistribution of electrons inside the body itself. Okay, هون سخيفين بس I want to mention them in case they come. Okay, هلا خلاص, let me actually finish the quiz. I don't think there's anything else I have to mention that wasn't in the quiz. A neutral conducting sphere is suspended by a thread. Neutral sphere brought close to a positive rod شو حيصير؟ أكيد is going to be attracted. نحن اتفقنا it will always be attracted on neutral objects. هون this formula I haven't used it before, but you have to know that the charge is equal to the elementary charge E multiplied by the number of electrons. Okay, and this makes sense. If each electron is 1.6 times 10 to the power of 19 coulombs, what if I have 5 electrons? How much is the total charge going to be? You just multiply 5 by 1.6 times 10 to the power of negative 19, right? So you can kind of say this formula makes sense. So Q is the final charge, okay, in coulombs. Okay, it has to be in coulombs. E is the elementary charge, which is also in coulombs. C, it has to be in coulombs. N is just the number of electrons. So this formula N is pretty self-explanatory. Okay, yeah, obviously the final charge equals how many electrons you have by the charge of each one. Elementary charge, basically what elementary charge means is that every electron has the same charge. That's why. Okay, what are they asking here? They're saying a polythene rod is rubbed against a paper sheet. You know that the polythene rod, when it's rubbed against a paper sheet, it's going to become negative, or the paper sheet will become positive, right? So the polythene rod gained the electrons, or the paper sheet obviously lost electrons, right? Subsequently, the rod acquires a charge of magnitude 5 nanocoulomb. Okay, so the charge Q, the final charge, is how much? 5 nanocoulomb. Can we solve if it's nanocoulomb? No, you have to change it to coulomb. Okay, from normal coulomb to nanocoulomb, you multiply by 10 to the power of 9. But if you're going to go backwards, okay, you're going to multiply by 10 to the power of negative 9. Because the prefix nano means times 10 to the power of negative 9. Okay? Okay, deal. You want to change now this nanocoulomb into coulomb. You're going to change it into 5 times 10 to the power of negative 9 coulomb. Okay. Take the elementary charge as 1.6 times 10 to the power of negative 19 coulomb. So this E, they gave it to us 1.6 times 10 to the power of negative 19. What are they asking? They're asking how many electrons do you have? So what do they want? They want N, right? So let's redistribute this equation. You're going to get N equals, take E to the other side, Q divided by E. صح? We can easily find, we know that the final charge Q is 5 times 10 to the power of negative 19 coulomb, negative 9 قصدي. And then the number, the elementary charge E is 1.6 times 10 to the power of negative 19 coulomb. Okay? Or you put this in your calculator, بس عشان I show you what's happening. Okay? Let me see. Fraction 5 times 10 to the power of negative 9 تحت عندك 1.6 times 10 to the power of negative 19. You're going to get 3.125 times 10 to the power of 10. Okay, يعني this is how many electrons we have. N equals this. Right? طب ماشي. هنا, when you rub them, they're both neutral at the start, right? So what happens is the paper sheet gave the rod some electrons, right? So the polythene rod, in other words, gained this amount of electrons, right? And the paper sheet also lost the same amount of electrons because it's between both of them, right? Like imagine عندك هون neutral, هون neutral. You rub them, this gives this 2 electrons. So what happens? The charge of this is going to become -2. The charge of this is going to be +2. Aren't they the same? It's equal charges in magnitude, but opposite in sign, right? So they have equal number of electrons being changed. The redistribution of electrons is equal, but one of them gained, one of them lost. Okay, the polythene rod, since it became negative, it gained the electrons. Or the paper sheet, since it's positive, it lost the electrons. Okay, very simple. I don't know what to tell you. Objects become charged when they lose electrons. This is written incorrectly. electrons have أكيد negative, protons have positive. An object that gains electrons أكيد gets negative. يعني what do I okay. هيدي know it. Will it come written? هلا honestly I don't think so. But know it in case they bring it in the multiple choice in the computer. Uh, just you know this one is the gold leaf. This one here is the insulating case outside. It has to be an insulator. This is the conducting metal rod. Okay. The charge is gonna flow أول شيء from the conducting knob. When you put it in contact, the charges will flow down to the conducting rod. It will repel if the charge is the same as the original charge as the gold leaf, and it will attract. The gold leaf will come closer if the charge given is opposite to what you originally had in the gold leaf. I'll explain it more in the second question that we're gonna solve after this, because that one it kind of requires you to know what charge. Anyway, هيدي أكيد is the insulating plug. These are two insulators, just so you don't have some leakage of charges. Memorize this, but for the second question, I'll kind of explain it a bit more. Okay, here they said the electroscope shown below was originally positive. Okay, so هون عندك positive charges. The gold leaves are spread out away. When another charge is brought, the gold leaf comes closer together. So يعني عندك this is a very very bad drawing. Okay, بس عندك هيك هيدا الميتال هون وعندك الجولد leaf هيك. Originally it's positive. When they got charge W, what happens? The gold leaf came closer. So this is now. So didn't it attract? It attracted. So that means it's opposite to positive. So that means the charge on W is negative. Let me explain for you how they got it. In the quiz for the AMS for term 1 week 5, what happened is they all asked, usually the electroscope is usually 90% of the time بحطوا لك negatively charged. Okay, when in the book they told us negatively charged. We got used to solving negative. But we had a note in the book that they didn't tell us to memorize it. Oh, if it's negative, خلاص, oh no. No. هنا they told us, if it's opposite, if the charge induced, the charge you're bringing, is opposite to the original charge, then it's gonna attract and come closer. If it's the same as the original charge, then it's gonna repel. So what happened, and I got this question wrong, I don't know why I didn't read the question properly, is they said the electroscope was positive at the start. It was a matching question where they asked us when leaf moves further, leaf comes closer, or leaf stays still. Okay, and you had to match it positive. They're asking about what's the charge of the object. What's the charge of the object that the object that you got close, the object that you put in contact with the gold leaf? Positive, negative, neutral. Leaf moves further. If the leaf's moving further, that means it's the same charge as the original. So it's going to go to positive. If the leaf is coming closer, that means it's opposite to the charge you had originally. So it's negative. If the leaf stays still, أكيد it's neutral. No, ما في شيء عم بيصير. Also, one question that some people got wrong is describe the function of the electroscope. Electroscope is used to determine what charge, what is the charge. I'll show you the book definition just so and I want to show you guys the book. Just take so I don't make anything up myself. These are all self-explanatory. Quantization. Let me see this. Oh, okay, yeah. I guess you could see this. Electric charge is quantized. I don't know why I didn't write. Did I not write this? Q equals an E on, صح? Yeah. Okay. Honestly, I think he's gonna get some multiple choice question from this page. Okay. You should maybe they might ask you what is true about electric charge. What is true about electric charge? You should know electric charge is quantized, and when we say something is quantized, like in radiation that that is required for the periodic in 1.9, energy is released in discrete amounts. Okay, so this electric charge is quantized means it's released only in discrete amounts. Any charge Q must be an integer multiple of the basic unit E. Okay, and you can either have 3 electrons, 4 electrons, 5 electrons, 6 electrons, but you can't have 2.7 electrons. No, it has to be an integer multiple of the basic unit E, right? Remember, Q equals an E, the number of electrons times E. The SI unit of electric charge is the Coulomb. Symbol 1 Coulomb. Okay, notice that Coulomb, capital letter, is the name of French physicist Charles. Okay, yep. Okay, Coulomb, the small letter is actually the unit. But when we say Coulomb, like big, it's actually the guy's name. They don't ask this shit, but okay. The principles followed throughout the CI. You should know that the unit of it is Coulomb. Although the Coulomb's form, yani, this is what is true about electric charge. You should know that the unit of it is Coulomb. See, it's quantized. Uh, it's any charge must be in general. Okay, although it's convenient. Okay. Uh, okay. Yeah, they're saying that 1 Coulomb is 6.25 times 10 to the power of 18 elementary charges. Okay, meaning that the elementary charge, each elementary charge is 1.6 times 10 to the power of negative 19. Okay, so a Coulomb is this amount of elementary charges. Each elementary charge is this amount of Coulomb. So they're opposite to each other. Okay? So 1 Coulomb is 6.25 times 10 to the power of 18 elementary charge, or each elementary charge, which is usually given, is 1.6 times 10 to the power of negative 19 Coulomb. So this could be a multiple choice question. Uh, 1 Coulomb is about 6.25 times 10 to the power of 18 elementary charge. That could be an answer. Uh, the charge of an electron is negative E. What is E? We said E is the elementary charge, each elementary charge. And each electron is 1.6 times 10 to the negative, it's 1.6 times 10 to the power of negative 19 Coulomb. But you know that electrons are negative, so it will take the negative E. So it's basically just negative. If you see, if you see the charge of an electron is, they don't put negative. If they put the charge of an electron is this, immediately you will know it's wrong. Okay, please do not pick it. But if he said the magnitude of the charge of an electron is yani, he didn't put the negative. If he said magnitude, then it would be correct. Actually, magnitude means you can make it positive. Okay, please don't get these silly mistakes. Okay, Q equals the charge of an object having an excess of any electron. See, if you're talking about electrons, then it's negative NE if you had a lot of electrons. But if you have a deficit and you're losing electrons, and it's Q equals NE. These don't matter in the question we solved here because they gave you, and usually they will give you, they will tell you they tell you the magnitude. They say see magnitude, right? So it doesn't really matter until you change your answer to positive or negative at the end. If you change the answer to positive or negative at the end, depending on whether you know the object is positive or negative. Like here, if they ask you to calculate the charge, let's say they didn't have this. Let's say they told you 5 electrons and this is elementary charge. Calculate the charge on the polythene. You know that polythene is negative, so that means the final charge you just make it negative. وهون they said calculate the final charge on paper. You know that paper is positive, you just do the calculation and you keep your answer as positive. Okay. Uh, okay. The charge of an object, when an object gains a positive charge, an equal amount of negative charge will be found in neighboring areas. This is what we said here. When this gained this, an equal amount is gained and is lost in this. Okay. Where am I? This is well known as the law of conservation of electric charge, which states that the net amount of electric charge produced in any process is zero. In other words, no electric charge can be created nor destroyed. Please, guys, these are all multiple choice questions that could come that were not in the quiz. Okay. Uh, you guys know the prefixes, and I've gone through this before. Milli is -3, 10 to the -3. Micro is represented by this symbol, it was 10 to the power of -6. Nano is 10 to the power of -9. Okay. Before I close this recording, a conductor allows charge to spread through due to the ability of some of its electrons to move anywhere with it. Okay, memorize this, please. In metals, only electrons can move. Okay, in an insulator, all electrons are fixed to specific locations. I think this came multiple choice, by the way, huh? In one of the AMSs. In conducting liquids, like molten salts and aqueous solutions containing ions, both positively and negatively charged particles can move. Sa. I remember this. This came. You need to know in solutions containing ions, like molten salts or aqueous solutions, both the positive and negative can move. But in metals, only the negative electrons can move. Okay? Only in the ions and the aqueous solutions, positive and negative can move. In some semiconductors, gaps left by electrons can move and cause conduction. This was actually in my notes, I think. Yeah, here. Yeah, okay, it was in my notes. And I went through it in the notes video. خلاص هيك I'm repeating myself. هيدا الجولد leaf, we went through it before. I think, no, it is in my notes. Yeah, and I said the law of conservation of electric charge, but I didn't describe all of these that I just said now. هون أنا where am I? Okay, so the gold leaf is used to, what is the use of it? Oh my god, the ebook صح. It's used to determine the electric state of an object. What principle does it use? It uses the principle of repulsion, okay, of like charges. Okay, the most important part of the gold leaf is, okay, this is, yeah, uh, Okay. This is just the شو اسمه the diagram. Okay. Okay. Yeah. So he put this in big bold letters. An increase in the divergence of the gold leaf shows that it has the same charge because it will repel more, right? So an uncharged conductor behaves as if it has the opposite charge to the cap of the electroscope. Huh? In humid conditions, electrostatic experiments may give unexpected results during being charged by an apparatus. Okay, this is yep. But you should know that in humid conditions, guys, electrostatic experiments they may give you unexpected results. Okay. خلاص هيك I think there's nothing left for me to say here. Uh, okay خلاص my ebooks يا أخي it's pissing me off. But anyway, I think we're done in this recording. Let me just double check عشان ما بدي أضيع شيء عليكم. Uh, I'll cut to when it actually loads. Hello. Okay. The Van de Graaff generator, I think, is also part of 2.8. قصدي 2.7. Yeah. Okay. هيدي it's part of the fingerprints is for the next quiz ما خصني هون. But the Van de Graaff generator is an electrostatic generator capable of producing enormously large electrostatic potentials. This is all written here. Uh, it has a rubber belt, two rollers. Okay. So basically what happens here is friction here will cause negative charges to build up. What happens is they earth it here. It's like it's a belt. It moves. Okay. The negative charges flow out. خلاص they go out, and then what are they left with? Positive charges. With these positive charges flow up to the metal ball here. Okay. Heck, it's done. Anything? Yeah. Okay. That's it for this one. Thank you so much for watching. Good luck in your exam.